Hello, welcome to Coffee Break with Microchip Technology. Coffee Break is our ongoing forum in which we discuss new and evolving technology, all in about the amount of time it takes to drink a cup of coffee. Welcome to the program. I'm your host, Eric Glatfelter. Joining us in the booth today is our moderator, Aliyah Fahout. Aliyah, welcome back.
Thanks, Eric, and thank you everyone for joining us today. We are currently live on YouTube, Facebook, and LinkedIn, and you can participate in today's episode by leaving your questions and comments in the chat, or you can email us at livestream@microchip.com after the broadcast. Don't forget to follow, like, and subscribe to our social media platforms too. Back to you, Eric.
Thanks, Aliyah. Our topic today is new secure authentication ICs for essential security, and joining us in the studio is Xavier Bignolet, Product Marketing Manager here at Microchip. Xavier, welcome to Coffee Break.
Thank you, Eric.
All right.
For having me.
So our topic talks about essential security. What are really the most essential things? Is it all about the key? How important is the key?
Yeah, we have actually. It's funny you mentioned that. It's all about the key. That's a statement one of our lead architects has been using for a long time. So if you think about the fundamental of security, there's a bit more than just the key. You have the key is a set of information, certainly that needs to be protected. Mm-hmm. But you also have, I call that math engine. It's really the cryptographic engine. It's just very complex mathematical functions that need to exist on the silicon right in the same secure boundary where the key lives. So you have the key, the crypto engine, and your secure boundary. That's your foundational brick right there. Okay.
Now, I see in our graphic in the bottom right, it says what a private key really looks like. So it's not that metal thing, it's that string of characters. Is that a fixed length of characters, or can you tell us a little more about that?
It's a funny analogy. We've had customers that were, implementing solution, and you get to that point in the discussion where, okay, but what is the key? Yeah. And we're like absolutely mesmerized by the question. No, it's not, they have a hard time to visualize what it is. At the end of the day, we have that example. It's a big chain of characters, right? Yep. Depending on the key strength, the size will vary, but it's a chain of characters, ones and zeros, essentially. And that chain is that key that you'll have to store in a protected part of your silicon.
Okay. Now, I know that at Microchip we've had security ICs for quite a while. What is driving the need for new additions to that portfolio?
So through the years, we've been pretty vocal about the needs of embedded security in the IoT space. Mm-hmm. So we've done that for, I think, since 2016, as far as I remember personally. But what else, right? Beyond the IoT, there are many, many other applications that are not IoT related that requires that need for embedded security. I'll call that minimum viable security, embedded security. Mm-hmm. Kind of stealing the idea, borrowing the idea of the notion of MVP, minimum viable product.
Okay.
So what does that look like? And in those segments, you think about, I'd say, three things at the top level. The first one would be really counterfeiting, fighting counterfeiting, protecting or preventing counterfeiting. The second one would be ecosystem control, which ties immediately into user experience. If I have to keep to a top three, you have more bullet points in that slide there, but this is really where it comes down to. So you generally have an ecosystem of accessory around the main computing unit that you want to control. I didn't say protect. Protect could be one of the reasons you want to address, but you want to control because maybe there's a third party that joins your ecosystem. That third party must provide the expected user experience. Now I'm into the user experience, right? So we take the counterfeiting, you quickly get into the notion of disposables. So that's the razor blade business model, right? The thing that you toss in the trash. But that could be not just a cartridge, could be cables, right? So those are the main reason. We have a lot of question on the bullet point about safety. Mm-hmm. So safety is regulated by ISO 26262, if I'm not mistaken. That has nothing to do with that. I'm going to shoot it, and I'll explain myself in a minute. When you talk about safety, you think 26262, that's a firmware with a microcontroller that's going to drive safety requirements by the spec. Mm-hmm. That's not what we're talking about. But if you have that software running, taking care of safety related functions, it lives on a board that would plug into a system And now, if that board is not authenticated, how much is it? How much can you trust what runs
The
on
system.
it? So the EV market,
Sure.
electrification of the car has a ton of cars plugged into it.
Yeah.
If you don't trust the car and you run a safety algorithm inside, what do you make of that?
Right. Okay. Okay. Interesting. So, what are the main markets that we're seeing these needs in?
It's the class everywhere.
The classic everywhere.
Everywhere. Now, so here we have medical, consumer, industrial, automotive, e-mobility, data center. So I'll start with data center and automotive. I just alluded to it briefly on the automotive side. Get a bunch of cards getting into the car that deserve to be authenticated before you run anything sensitive, aka safety-related stuff, right? Data centers, the same stuff. They have actually a standard in place that the Open Compute project has been defining, where they want cars to be authenticated as they join the data center ecosystem. So they're trying to make that part of the standards. So that's not a discussion anymore. That becomes pretty powerful for us. The other segments there, medical, it's been really interesting. We've seen an uptick there for a couple of years where authentication comes in for, brain sensor type of application, breathing tubes type of application, because those companies do suffer. So they have the main product and they sell what goes with it, so the breathing tube and the mask and whatnot, but that's being counterfeited. There's a lot of, honestly, profit those companies makes on that, so they want to protect that and preserve the user experience. We're back to that again. Industrial, if I have to give an example, imagine an elevator company, maintenance service come into the elevator to replace a card. There you go, you get your authentication to the card to prove that the maintenance service delivered the legitimate card and the operation of the elevator is insured.
Yep.
But card, you don't want anything bad to happen in the elevator.
Right. Okay, so wow, a broad array of markets here, and obviously there's going to be pros and cons and trade-offs, and how you implement security in these markets. How do we help customers? What are we providing for them for these different markets?
Looks like you prepared the question. It's a nice setup. It's a nice setup for what's coming. So what you said is what we saw coming from the market as a requirement is diversity.
Yeah.
We had to offer more diversity in our portfolio with minimum viable embedded security functions. Just that bare minimum that is just enough yet secure to our customers. And our customers are all over the various markets.
Sure.
So how do we address that? So we took we've learned what works, what's being consumed in terms of cryptographic functions, obviously related to, involving the key storage. And we come up with the portfolio that we have here, the portfolio extension we have here. If you look at it, you're going to find we have 1 or 2 cryptographic functions per device. Yes, that's about that. So you have an DSS sign to create a signature for asymmetric authentication. You do an HMAC or a SHA-256 MAC. That's about it. So with those 3 functions, we build a puzzle of offering to provide, again, that minimum viable, very cost-efficient solution to address all those functions. The other thing we invested in and delivered here is the form factor of the package itself.
Okay.
So now we step a little bit beyond security, but it does take this extra effort, that extra investment to address especially the disposable market.
Yep.
Those throwable things, the cables, the breathing tubes, the cartridges and stuff. So that's where you see those 2-pin and 3-pin packages there. What they achieve there is you eliminate the PCB inside the disposable.
Okay.
So you get rid of all the electronics, and that helps the supply chain to keep running as they are used to.
Yeah. Okay. So you have an electronic device, but you don't need to be an expert in electronics. You can focus your expertise on what you're already doing.
Exactly. Yeah.
Okay.
And if you can bounce back on that, if you look at the contract manufacturer that are there in the world that deals with the cartridge, so what we generally see happening, the contract manufacturer of the cartridge, the tube, the table, is one location in the world. There's another CM with another location in the world, whether it's the same company or not, that would do the host, right? Let's say imaging the display with the imaging for the medical stuff. So that contract manufacturer that's somewhere else in the world doesn't have any electronic capability to go and test anything that would go inside there.
Okay.
So let alone adding a PCB, there is a lot of prohibitive things like that from a process standpoint that happen. Now when they come in, they take the parts, glue it in, and there is some minimum testing that's happening when the two entities meet each other, when they start boxing them and whatnot, so they do testing later on.
Okay, so when we talk about two devices to that too, let me ask you about, again, going to the graphic, what's the difference between a symmetric and an asymmetric device in this context?
Right. So first of all, if I want to give you a short answer, we have a lot of tutorials on the topic. If you go check on Microchip University, there is a cryptography primer that goes into pretty deep details on this concept, but in a few seconds, for the sake of the coffee break there, symmetric, you have the same key on the accessory and the host.
Okay.
Not necessarily the best practice, but so now you need to decide if you want to protect both sides or only one side. So you need a threat model to decide that. You can diversify those keys to make them unique per devices, much more elegant implementation. So at the end of the day, same key, one on each side, call the other side. The asymmetric authentication, the two keys on each side are different, but mathematically related.
Okay, okay, interesting. All right, so fascinating topic. Now, there's a lot going on here, so if somebody was listening to this and they wanted to learn more about it, how would they get started?
So we have three main components. The first one would be getting you guys the board. I don't know if the camera can zoom on the board there. Up, right there. Got the focus right. So what I have here is the base board. That's also on the slide. That's what will have the microcontroller. You'll have your debugger on the right here on the front. And we have add-on boards. So the set of add-on board is illustrated on the slide. We have a socketed version here that I was just showing a second ago. You have other add-ons that have the parts directly soldered on. And you come and program your security use cases. That's what brings the Trust Platform Design Suite software tool that runs on your laptop to help you prototyping your use case with a secure element that sits on those boards. The other big thing the Trust Platform Design Suite gives you is a complete code example, so you don't have to go develop it. We've done it for the customers. And the last major item the Trust Platform Design Suite addresses is it offers a configurator which represents the memory map of the secure element and helps you to configure it and set up the secrets, set up the system to get into our secure key provisioning service. So it's a service that Microchip offers that leverage our factories that are equipped with hardware secure module and that stuff to provision, to load secrets. Secrets could be keys, data, into the silicon themselves. So the tools get you into that process, which is obviously the third big pillar, the secure provisioning service.
Right, okay, awesome. So hardware, software, tools, boards,
the
all those things, great. All right, so let's check in with Aaliyah and see if we have any questions from the viewers today.
Yes, Eric, we do have a few questions that we received via email. The first one is, what type of attacks do the new devices protect against?
All right, so that's always a sensitive one. What type of attacks? It's mostly the counterfeiting. It's physical access to the cartridge. So what we see happening generally, especially when the world of accessory and disposable that have nothing security-wise, and that's where problem happens, and the phones start rigging to Microchip. It's a physical attack on the accessory, the disposable, the cartridge. They want to protect it. They want to mitigate that as much as possible. Then what should really happen is you have a threat model, you assess the risk you want to absolutely protect against, the ones you have that are tolerable, and you decide on the technology. So definitely a physical attack on the cartridge side of the business.
Okay.
Great. And I have a second question for you, and it's kind of a loaded question. So if we have key to load in the silicon, someone in manufacturing can intercept the keys and spoof them. What do we offer to fight this problem?
All right. So I mentioned in the ecosystem of what we offer, we have the kits, we have the Trust Platform Design Suite, and we have that secure key provisioning service. That's exactly the goal we're trying to address there, is to isolate virtually everything we can from the keys. And that includes third-party intervention in the supply chain, everywhere we can. So the idea is to have the the ideal, I'd say, is to have the silicon manufactured by Microchip, provisioned by Microchip, because it segregates any third-party exposure during the supply chain to happen, essentially, because that exchange between the keys and the loading of the keys in silicon happen within our secure environment. So we have different certification of our factory plants that proves that we are following some healthy security processes. So our customer base have used intensively that service because they do recognize that anywhere you would go at a contract manufacturer, literally anywhere in the world, you have what? You have Linux system, that's your laptop next to the testers.
Yeah.
You have the operators that runs it. They have turnovers of those operators. So it could leak. Things could physically leak anytime, anywhere. And on top of that, those things are networked right inside of the CM factory. So more backdoors to access Linux systems, stuff like that. Those all things are real. If we look at the news, it's been happening.
Awesome. And I have a question that we received from YouTube, and it is, what would drive the decision or be key considerations to use one of these ICs versus using a PIC24 or PIC32 with an integrated crypto engine?
Yeah, so the we have to separate cryptography away from, no, I shouldn't say that. Cryptography is just a math. You basically, if you go back to school and take the basic function, y equals function of x, is that security alone? No, right? Because if you have either x or if you have x, you can calculate y. You got a security problem there.
Yeah.
That's what cryptography is, just a mathematical function. So if you just want to compute a mathematical function, your PIC is just fine enough, but we can't talk about security. Now you have that data, the key, that X, if I have to continue with my analogy, do you need to protect that? And that goes back to your threat model. Do I have to protect my X function, my key essentially, or can I live without it? So that's your decision, really. It really depends on your threat model. Do you want to use math accelerators, or do you want to implement, embedded security, aka authentication, in that scheme?
Okay.
Great. And I believe we have one more question for you. But before I read you the question, we received a comment in our social media, and they said, "Nice to see the expanded package formats. It's been nice to see the continued innovation by Xavier's team over the years." So that's a great comment.
Work hard at it.
All right. Last question for you is, what's the difference between the 2-pin and 3-pin packages besides the pin count?
Yeah, so besides the pin count, there's a little trick we use. It's a common, well, not a common, but it's a practice in the semiconductor industry. When you see that, basically add a capacitor inside the 2-pin package to shrink the package even more. So now you have the capacitor hooked up to the power line that will receive enough energy to load the capacitor, and the same line is used by the data. Now you run the data on top of the power supply. There's enough energy on the capacitor to hold enough energy to compute, to run that crypto acceleration, hits the key, create that response, and back and forth. So that's really, that capacitor is not integrated into the 3-pin, which sometimes is part of the customer requirement too. They like to have a broader pads for the sake of contact exposure and stuff like that. So that's the big difference, the capacitor.
Okay.
Those are all the questions I have for you guys today. Don't forget to follow, like, and subscribe to our social media platforms today. And thank you for tuning in to Season 9. And you can check out our YouTube channel and follow our Coffee Break webpage at microchip.com/coffee break to see more. And we will see you in Season 10. Back to you, Eric.
Awesome. Thanks so much, Aaliyah. Thank you, Xavier. And thank you to our audience for joining us. As Aaliyah said, check us out at microchip.com/coffee break. Sign up for subscriptions, see our upcoming schedule, and you can always peruse our library of previously recorded sessions. Thank you again, and see you next time.